In order to simplify this expression, we're first going to express each of the trig functions in terms of sine and cosine. So tangent theta is going to be sine theta over cosine theta. Secant squared theta is going to be 1 over cosine squared theta. Tangent theta again is sine theta over cosine theta. And cosecant squared theta is 1 over sine squared theta. Now we can take each of these large fractions individually and remember that dividing is the same thing as multiplying by the reciprocal. So we're going to rewrite the first fraction as sine theta over cosine theta times cosine squared theta over 1. That's going to be added to sine theta over cosine theta times the reciprocal of our other denominator, so sine squared theta over 1. If we complete this multiplication, we'll end up with sine theta times cosine theta plus sine cubed theta over cosine theta. From here, we'd like to add these two terms, but we have a fraction and it has cosine theta in it, so the way we're going to get around that is we're going to multiply the left-hand term by 1, but 1 in the form of cosine theta over cosine theta. This is going to give us the same denominator and allow us to add these two terms, but it isn't going to change the value of the expression. So this will give us sine theta times cosine squared theta over cosine theta, so now we have the denominator we need, plus sine cubed theta over cosine theta. And now we can add the two fractions together by adding the numerators and putting them over a single denominator. So we'll have sine theta cosine squared theta plus sine cubed theta all over cosine theta. From here we can factor out a sine theta in the numerator, and that's going to leave us with cosine squared theta plus sine squared theta, and that'll all be over cosine. And cosine squared theta plus sine squared theta is a Pythagorean identity. It just equals 1. So that's going to leave us with sine theta over cosine theta, which is of course equal to our final answer, which is tangent theta.